Hello again. Today we're going to do Module 5, Lesson 8. We're going to represent parts of one whole as fractions with number bonds. Okay. Now, before we start, we're going to do an application problem. Everything's fixed up here. Now let's read it. Mr. Schwartz went to a coffee shop before school. He spent 1/6 of his money on a coffee and 1/6 of his money on a bagel with cream cheese. How much of his money did Mr. Schwartz spend before school? Okay, so way back when we were doing type diagrams, let's make a tape diagram. So if he spent 1/6 on a bagel, how many pieces of tape am I going to need? Well, 6, right? Okay, so I know if I make thirds, I can make them more equal if I cut them in half. My pieces, my drawing is a better drawing. Okay, so this would be 1/6, this would be 1/6, all the way, right? Okay, now, this part right here is his coffee. And this part right here would be his bagel with cream cheese. So, how much of his money did he spend? I want to know this much, right? Because he didn't spend any, we don't know what he spent this much money on, did we? He's probably still in his pocket. Maybe he'll use it on his way home. So how do I answer that? Well, they're divided into sixths, and we use 2 parts. So the answer would be 2/6. Now let's put it in a statement. Mr. Schwartz used 2/6 of his money. Make sure you put a period. Good. Now, before we get started, I want to talk about number bonds. See what you remember. Now, if I put 4 here, what can go in here? Now remember that these two added together have to equal this. So give me some ideas. Well, I could do a 2 and a 2, couldn't I? Can I do anything else? What about a 1 and a 3? Okay, anything else? No, because if I switch them around, it's still the same number bond. So if I do 3 and 1, still this number bond. What about this? Can I do this? What if I do this? What if I do that? Can I do that? Absolutely, I can do that. Because 1 plus 1 plus 1 plus 1 is 4. Right? Do you remember that? From way a long time ago. Okay, so we're going to be doing number bonds again. But remember that the parts have to equal the whole. You add up the parts and they will total this number here. Okay. Now, instead of writing 4 here, I'm going to write 1. Now, I'm going to change that. Remember this number bond that we had here? Look like this. I'm going to change that up a little bit. It's going to look similar, but it's going to have the same job. Okay, so let's see. If 1 is my whole, and I have 4 sticks coming out of my number bond, what would my fraction be? Now, in order to get 1 whole, I have to cut up the whole, right? So it's going to have to be a fraction. It can't be whole numbers like this, can it? So I've got 4 parts, so I need to make them into fourths. Now, how many fourths equal a whole? 4 fourths, right? So if I draw my picture here, if I cut my halves in half, I get 4. So 1 whole would be this whole rectangle, each one of these partitions would be one of these circles in my number bond. So if I'm writing this here, I would have to write it like this, right? Well, then I have to do the same thing over here. 1/4, 1/4, 1/4, 1/4, because 1/4 plus 1/4 plus 1/4 plus 1/4 does equal 1 whole. Okay? Let's try a different one. We're going to do something still similar. Now this time, I want you to decompose. That's what we're doing when we take it apart, right? 1, and this time I want you to, last time we made them into fourths, I want you to make it into fifths. If I ask you to make it into fifths, how many sticks coming out of my number bond would I need? Fifths. Well, that would be 5, right? Okay, so 1, 3, 4, 5, and then I make my circles so I know what to fill in. Now each one of these is going to be a part. If I make my picture down here, now keep in mind that you don't always have to have a picture. All right, there's 1, 2, 3, 4, 5. So this would be 1/5, 1/5, 1/5, 1/5, 1/5. Now, when you're taking apart the 1, when you're partitioning it, I want you to think of this picture. Think of making a bar and cutting into pieces, or a tape diagram cutting into pieces. Okay, so if that's the case, then what goes in each of my bubbles? 1/5, right? All right, so here we go. Good. So 1/5 plus 1/5 plus 1/5 plus 1/5 plus 1/5 equals 1 whole. Is that true? Yeah, here's my proof. Here's my proof that it's true. Okay, now let's change something up with this number bond. I have to erase this right. Well, nope, I'm not going to erase it. I want to keep it. Now I'm going to change it up. Ooh, I still have a number bond. It still has 1, but this time I'm only going to do 2 sticks coming out. Okay, now I'm going to circle some, and that's what's going to help us put it in the right spot. So I'm going to circle these, and these are going to go in here. Oh, so how do I do that? How do I do that? Well, this would be 1, 2, 3/5, right? So I'm going to put 3/5 here. Now, 3/5 plus what would give me a whole? 2/5. So I'm going to put 2/5 right here. So 2/5 plus 3/5 equals 1 whole. Does that make sense? Well, sure it does, because 2 plus 3 is 5, and 5/5 is 1 whole, right? Okay, it just means I don't have to draw so many sticks coming out. Okay, I want to do it again, really quick. But this time, let's go back to our fourths. Okay, so this is 1, and we had 4/4, right? But this time I want to have only 2. What could we have to make 4? Well, let's have 3/4. If I have 3/4, how many more fourths do I need to make a whole? Think of this picture. You don't have to necessarily draw this when you're doing your work, but I want you to think of it. Okay, so I have 3/4. They're shaded. How many more do I need to make a whole? I need 1/4. So 3/4 plus 1/4 is a whole. 3/4 plus 1/4 is a whole, right? Okay, let's do one more, and then we're going to call it good. Okay, now this time let's do 6. Okay, so we're going to make it. We're going to make it into 6. Please decompose this into 6, which means we're going to need 6 pieces. 2, 3, 4, 5, 6. Almost looks like a spider. Okay, now in each one of these, since we have 1, 2, 3, 4, 5, 6, the bottom number has to be 6 because that's how many we decomposed it, or we partitioned it into. Okay, so that would be 1 in each one of these, right? 1 6 plus 1 6 plus 1 6 plus 1 6 plus 1 6, right? Till we get to 6. Now, I'm lazy, and I only want 2 sticks because I can add. That's cool thing about math. You can be lazy and you can use other thinking. So let's use other thinking. Okay, now I'm going to group some of them. What if we group these? We put these right here. What would I write? Well, that would be 1, 2, 3, 4, 6, right? 4, 6, 6. And how many do I need to make 1? Well, 4 plus what gives me 1? 4 plus what gives me 6? 2 of them. 2 6s. So we would write 2 6s. So 4 6 plus 2 6 equals 6 6. And another way of saying 6 6 is 1 whole, right? Because if I have my rectangle, here's my proof. I divide it into thirds, and then I cut the thirds in half. That gives me 6 pieces. 1, 2, 3, 4, 5, 6. Okay, if I have 4 6s, okay, and I add 2 more, I will have 6 6s. If I have 1, 2, 3, 4, 5, 6, 6 6s, I have 1 whole rectangle. I'll have the whole thing covered, wouldn't I? All right, so one way of saying whole is just 1. All right? All right, well, good luck, and I'll see you tomorrow. Have a good day.